Hello everyone. Let me start with a thought. Why do summers feel hotter today than they did just a few decades ago? The answer lies in one of the most urgent issues of our time: global warming. Global warming simply means the rise in Earth's average temperature. But the real question is, why is the planet heating up? The culprit is greenhouse gases like carbon dioxide, methane, nitrous oxide, and CFCs. Ever since the Industrial Revolution, these gases have steadily increased, trapping more and more heat in the atmosphere. As a result, Earth's temperature has already risen by about 1.1 degrees Celsius compared to pre-industrial levels. And that tiny rise is making a huge difference. Let's dig into the physics. The sun gives us energy at about 1361 watts per square meter, called the solar constant. Around 30% of that is reflected away by clouds, ice, and the Earth's surface. This reflectivity is called albedo. The rest is absorbed. Now here's where greenhouse gases step in. Instead of letting heat escape back into space, they absorb infrared radiation and re-radiate it back down. The result? An energy imbalance. Roughly 0.6 watts per square meter extra heat gets trapped. In terms of physics, the imbalance can be written as delta Q equals I multiplied by open bracket 1 minus alpha close bracket minus E out, where alpha is albedo and E out is outgoing radiation. This small imbalance, when integrated over the globe, leads to a significant long-term temperature rise. So what's driving this imbalance? Human activity. Burning coal, oil, and natural gas releases nearly 36 gigatons of carbon dioxide every year. Deforestation removes forests that would otherwise absorb this gas. Agriculture adds methane and nitrous oxide, both powerful greenhouse gases. And industries produce synthetic gases like CFCs that are thousands of times more effective at trapping heat. For perspective, one molecule of methane is about 25 times more effective than one molecule of carbon dioxide in holding heat. Quite alarming, isn't it? Now, what happens when the planet heats up? Ice caps and glaciers melt, causing sea levels to rise. Coastal cities and island nations are at risk of submersion. Weather extremes are becoming more frequent: stronger cyclones, prolonged droughts, and deadly heat waves. Oceans absorb more carbon dioxide and become acidic, threatening marine life. Even agriculture is disrupted as rainfall patterns change and fertile zones shift. Sea levels, for example, are already rising at 3.3 millimeters per year, a clear danger for low-lying areas. But the story doesn't stop there. Global warming is accelerated by feedback mechanisms. Consider the ice albedo effect. Less ice means less reflectivity, which means more absorption, which in turn melts more ice, a vicious cycle. Another example: warmer air holds more water vapor, and water vapor itself is a strong greenhouse gas, so warming increases further. There are negative feedbacks too, like more plant growth absorbing carbon dioxide, but overall, positive feedback dominates. Physicists express this using the equation delta T equals delta Q divided by lambda, where lambda is the climate sensitivity parameter. The key idea: warming triggers more warming. Let's take a quick calculation to cement this. Suppose the net radiative forcing, delta Q, is 2.0 watts per square meter. The climate sensitivity parameter, lambda, is 0.8 watts per square meter per degree Celsius. The equation is delta T equals delta Q divided by lambda. Substituting values, we get delta T equals 2.0 divided by 0.8, which equals 2.5 degrees Celsius. So just a small increase in forcing results in a big rise in average global temperature. This is why climate scientists are so concerned. Small changes lead to major consequences. So, how do we fight back? The most obvious step is to reduce our dependence on fossil fuels and move toward renewable sources like solar and wind. Improving energy efficiency in transport, buildings, and industry is crucial. Afforestation and reforestation can rebuild carbon sinks. And international treaties like the Paris Agreement set global targets to keep warming below 1.5 degrees Celsius. Each of us can contribute to conserving energy, reducing waste, and using sustainable alternatives. Together, these measures form a multi-pronged approach to combating climate change. So, to wrap up, global warming is caused mainly by human-driven emissions of greenhouse gases. This disrupts Earth's delicate energy balance, traps heat, and drives changes in climate. The consequences are melting ice, rising seas, extreme weather, and ecological shifts. The physics is clear. Through radiative forcing and feedback mechanisms, a small imbalance can amplify dramatically. The only way forward is mitigation and adaptation, urgent, collective, and science-based. I hope this session gave you a deeper understanding of how physics explains global warming and why it's one of the greatest challenges of our century. See you in the next session with another fascinating concept of physics.